This is the second video in the aerodynamics series, a series brought to you by The Science of Flight, a new brand here on YouTube. The brand, of course, is dedicated to aerospace engineering, education, and software. So in this video, we're going to talk about aerodynamic topics that are found in a college curriculum, as well as aerodynamics in other fields. So let's go ahead and get to it. We will now briefly cover some of the common topics in undergraduate engineering classes studying aerodynamics. A study of aerodynamics typically starts with a study of the properties of air, an introduction to the standard atmosphere model, and sometimes covering airspeed measurements like true airspeed versus calibrated airspeed versus equivalent airspeed. Flow fields and objects used to simulate a flow field, like sources and sinks, are also introduced, usually in an Aero 101 course. After the discussion of flow fields, usually comes discussions of pressure distributions, lift and drag curves, forces and moments, wing geometry, and even coefficients. After learning the geometry of airfoils and wings, many different theoretical analysis techniques are then covered or taught. I'll talk a little bit about what some of those techniques might be on the next slide. For instance, in my undergraduate studies, this was the end of our Aero 101 curriculum. And starting in Aero 102, we looked at boundary layers, viscous effects, turbulence, and what I thought was so much fun, shock waves and expansion fans. Sometimes an aircraft performance section might be thrown in with your normal stuff in an Aero 102 course, or sometimes it might actually be left to a separate flight mechanics course. And in my undergraduate program, a wind tunnel testing class was its own course, as well as CFD, or computational fluid dynamics. Now, the plan for this series on aerodynamics is to begin with an in-depth coverage of these basic undergraduate aerodynamic coursework, and then to move on to more advanced topics such as hypersonics and modern advances in turbulence models. Now, if there's a specific topic you'd like me to cover, let me know in the comments below and I can add it to the curriculum. Aerodynamics is not solely in the aerospace engineering field, as it's actually found in many other fields, each with different design goals. For instance, the automotive industry is concerned with the flow of air around a car design. It's not just to determine the drag on the car as we immediately think of when we hear aerodynamics in cars, but the flow around a car is also examined in terms of the noise, right? They want to determine the noise that the passengers inside experience as they're driving the car, or maybe even the noise that some of the bystanders on the street experience as the car drives past. Another big concern in kind of the automotive industry is the vehicle's handling and stability at higher speeds. Now, at higher speeds, the aero forces on the car are increased, and so their concern is they want to make sure that the forces exerted on the car due to the airflow around the car doesn't have a negative impact on the vehicle's handling and stability. They want to make sure that you're able to continue to be safe while you're driving, and the airflow isn't going to cause you to veer off or lose friction in your tires and spin out, anything like that. And along with the flow around the car, the flow through the car's engine has recently become a major design consideration for the car. and with great benefit for us as the consumers, because a portion of the increase of the fuel efficiency of modern day cars is due to the fact that the airflow through the engine is being considered nowadays, as opposed to in the past when it wasn't really considered how the air flow through the through the intake, through the engine, through the exhaust. It wasn't really considered before in great detail, and it's being considered now, and we get some fuel efficiency benefits from that. Now, another transportation vehicle that is concerned with aerodynamics is the boating industry. Now, interestingly, aerodynamics is not that different from hydrodynamics, or the study of water in motion, with the difference usually boiling down to the applications considerations. The mission specs kind of dictate a little bit the difference between an aircraft and a boat, but they kind of rely on the same principles and same methods. What's interesting is that boats nowadays can actually undergo both hydrodynamic design kind of below the waterline, as well as aerodynamic design above the waterline. Depending on the boat that it is, it might actually have both hydrodynamic and aerodynamic design considerations or design methods performed on it. Now, another field that is interested or considers aerodynamics is the designing of buildings. Now, it is usually used to determine the forces on the buildings due to the flow of air around the outside of the building, as well as the airflow between the buildings, to make sure that the airflow at the street level is human friendly. Obviously, we don't want the wind whipping down kind of at street level. We don't want the wind whipping through really fast and knocking people over or causing issues for the people kind of down walking on the street. So we might look at the airflow between buildings, not just around an individual building, but kind of between buildings and how that affects the airflow down there at the street level. It's also actually sometimes used on a city size scale or a neighborhood size scale as well, to try and kind of manipulate the climate in the city or in the neighborhood, and create what they call microclimates. Now, the goal of microclimates might be to kind of make pollution move easier through the city, so that you can kind of get it out of the city and have cleaner air. Or maybe it might be a temperature thing where you're wanting to remove some of the heat from the concrete, or what have you. So sometimes on a city size scale, they might look at aerodynamics to try and create microclimates, and that's kind of some of the newer eco-friendly cities are kind of doing this analysis on their cities using aerodynamics. Now, another really popular one is that aerodynamics is also used in atmospheric models to try and predict the weather. So on the news, when you see the weather person giving their nightly prediction on what the weather is going to be the next day, that's usually their prediction is based on a computer model, which is based on aerodynamics of the atmosphere, along with some other stuff as well. But aerodynamics does play a role in that model that they use. Now, just kind of the last big one that I'll chat about is sports. Aerodynamics is also used in the sporting industry as well. The flow of air around a ball can actually affect the trajectory of the ball as it travels through the air. For instance, in sports like soccer and baseball, the trajectory of the ball can be hugely impacted by the aerodynamics of the ball. For instance, when the soccer player, the baseball pitchers actually put some spin on the ball, they're able to make the ball's trajectory curve, and this definitely increases the difficulty and the entertainment value of the game. It makes it harder for the opposing team to hit it because it's harder for them to kind of predict where it's going to be, and that of course is using the Magnus effect. So it's definitely a major consideration in ball design for the sports industry. For instance, the dimples on a golf ball are actually there for aerodynamic reasons. Simply put, the dimples affect the type of flow around the ball and thus reduce the drag force on the ball, causing the golf ball to travel further. Now, we'll probably talk about this a little bit more on the video when we cover the difference between laminar versus turbulent flow. But yeah, the dimples on the golf ball are actually there for aerodynamic purposes, to reduce drag, make it travel farther. So these are actually a few of the examples of aerodynamics in other fields, and I'm sure there are plenty more examples. So the series is kind of focused on an aerospace engineer's perspective of aerodynamics. However, the knowledge in this series can be applied to these other fields as well. The knowledge really transfers over easily. It's not a very different field if you look at aerodynamics of a car versus aerodynamics of a plane. So you can easily watch this series if you're not an aerospace engineer. Maybe you're working in the car industry. You can definitely watch this series and then learn a lot of good principles and gain some knowledge that will help you in your field. That's the end of the second video. If you like what you saw and you want to see some more, then go ahead and like the video, comment below, subscribe to the channel, and when you've done all those, go ahead and click on the link to the next video. The next video is going to cover aerodynamic methods, so go ahead and click on that link and I'll see you in the next video.